In rotational mechanics, we focus on how objects rotate around a fixed point called the axis of rotation. Today, we will derive the fundamental concept of torque. To rotate an object, we apply force at a distance from the axis. This distance, represented by the vector r, is known as the position vector or the lever arm. When a force F is applied at an angle θ relative to the lever arm, only a specific component of that force contributes to the rotation of the object. We can break the force into two components. The parallel component, F cosine θ, pulls away from the axis and causes no rotation. The perpendicular component, F sine θ, is what creates the turning effect. Torque, represented by the Greek letter tau, is defined as the cross product of the position vector and the force vector. Its magnitude is the product of r, F, and the sine of the angle between them. Torque is maximized when the force is applied perpendicularly to the lever arm because the sine of 90 degrees is 1. If you pull directly away from the axis, the torque is 0. Just as force causes linear acceleration, torque causes angular acceleration. In rotational form, torque equals the moment of inertia I multiplied by the angular acceleration alpha. Torque is a vector quantity. We use the right-hand rule to find its direction. Curl your fingers from the direction of R toward F, and your thumb points in the direction of the torque vector. This explains why longer levers make work easier. By increasing the distance r from the pivot point, you can generate a much larger torque with the same amount of input force. Torque also performs work. When a constant torque rotates an object through an angular displacement delta θ, the work done is the product of the torque and that displacement. To summarize, torque depends on the force, the distance from the pivot, and the angle of application. It is the rotational equivalent of force and is essential for calculating angular motion. Understanding torque allows us to engineer everything from simple tools to complex machinery. Thank you for following this derivation of rotational mechanics. Generated by Vision Solve AI.